ambiguity related to so many terms in the field of analytics and data science. It is extremely easy for even someone who is in the field to be able to correctly differentiate among different terminologies and jargons that are used in this field. The story gets more interesting, especially if you're a fresher with absolutely no background. You just pop out of your college and enter into a world of career opportunities. And outside in the world, it's a blessing to find institutions latch onto you till you enroll in some of their promising courses with a certificate from either tech giant or some of the Tier 1 or Ivy League universities. Now, if you're looking forward to make a career in the field of data science, you should definitely first try to educate yourself a bit more on some of these freely floating terms and jargons which are made extensively fanciful by the media. Data mining, data science, data analyst, machine learning, analytics, too many terms. But are they really all different, or all of these actually point to the same domain of study? If you don't want to fall prey to marketing gimmicks who would lure you to cross-sell or upsell different exorbitantly high-priced courses, I assure you, you would be able to save your hard-earned money by making the right choice. An informed choice to find out if a course is absolutely right for you, if this is what you were actually looking for, and in the right depth that you would really expect. My goal is to make sure that if you enroll in a course, you do that in an informed way. Now, in addition to the already overcrowded web cloud of jargons, this gets further intensified with the terms describing specialized niche. For example, NLP practitioner, a chatbot specialist, a computer vision expert. While all of these are core areas, and anyone who is hired for such roles is expected to specialize in one or multiple of these areas of study, all of this falls under the core umbrella term data science. If you would ask me personally, I prefer to use the term data science because it highlights two of the most important things that most of us do. We deal with data. Now, data could be related to the network data, it could be supply chain data, it could be financial data, defense data, geospatial data, it could be any data, right? And all of the techniques or methodologies that we apply to come up to a conclusion, or more suitably we would use the term inference here, is scientific in nature. One important thing though, there's a confusion, or there's often this debate whether this is a science or an art. Now, according to my personal opinion, I think it's both actually. Because whereas the process and algorithms used are scientific, which procedure or algorithm to apply in which particular context is more of an art. There is no one formula to solve a problem, and there is no guarantee that an approach used today will hold as good as it is today, even for the next time that we are using it. So, as rightly pointed out by Meta Brown, author of Data Mining for Dummies, there is no one single definition of the term data science and data mining. There are various perspectives, right? And after there's one article that Dr. Meta Brown, she has posted on Quora, which highlights the fact that all these terms basically boil down to the same one or single idea of data science. All that being said, it's important to know a few important concepts that is extremely critical in your understanding and spotting a difference between the popularly used terms. Let's see the illustration here. Now let's figure that data science, let us for a moment forget all textbook definitions and whatever you have heard from anywhere, for a moment. Figure data science to be a field of science that helps make meaningful insights out of data just come to your hand and you want to make some meaningful insights or generalizations about this data, right? Which has some use. It could be used to society, it could be used to business, it could be used to any entity. Now, this now has multiple dimensions depending on tools and technologies that would be used. For example, if we look at AI or artificial intelligence, this is the branch of computer science that deals with the simulation of human brain, or it indicates intelligent behavior. Now, there are two keywords to focus here. One is artificial, that is something which is made artificially or man-made, or induced or injected intelligence into a system. The second keyword is intelligence. It is important to understand what is intelligence and how exactly is it different from intellect or memory or knowledge. We will cover this topic in more detail when we cover the topic on artificial intelligence. Now, broadly, there are two types of AI. One is weak or the narrow definition of AI, where in this particular context, AI is applied to a certain area. Example, virtual assistants or chatbots. In this type of AI, you mostly try to solve a set of problems where the algorithms are not required to perform tasks on any of the unrelated areas. On the other hand, you also have something known as a strong or generalized AI. Now, this type of AI has much wider scope in terms of applications where it can interact with multiple unrelated tasks, and they operate almost at the same level of intelligence close to a human brain. Machine learning or ML is a sub-branch of artificial intelligence which deals with making computers or machines learn without being explicitly programmed. Imagine you are looking at an email system, and this email every day generates a lot of spam emails and non-spam emails. Your task is to classify emails coming in your folder inbox, whether they are spam or not spam. Now, in typical data analytics projects, we not necessarily always have to deal with machine learning models, right? For example, in this particular example, if you were to classify mails as spam or not spam, you could start off with defining certain rules. For example, if a mail contains a particular keyword, then mail is a spam. If the mail doesn't contain a particular set of keywords, it's not spam. So this is rule-based, and these rules are hard-coded in your algorithm to be able to classify something as a spam email versus a non-spam email. On the other hand, a machine learning model, doesn't really need a rule-based system. What we are telling here is that we want the machine to learn from the data or the examples is fed. Right. Now, this machine learning then is not exactly the same as the type of predictive modeling or data mining tasks that is generally performed traditionally. So this is a little bit different from just applying models. It could be rule-based learning, it could be any other sort of models that you build, but you are not explicitly you are explicitly programming something. So that's not machine learning. In machine learning, you are not doing any explicit programming. Now, machine learning has different areas again. The first area is known as supervised machine learning, where there's some degree of supervision required to train your machine learning algorithm. Next, there is unsupervised machine learning, where the algorithm takes care of everything on its own. And there's something called semi-supervised machine learning, which is a hybrid between supervised and unsupervised. There's also reinforcement learning, where every action that an agent takes, either the agent earns a reward based on his actions or earns a penalty, and based on whether it has taken a wrong step, right, and incurs a penalty, it in the next step it further improves its performance on the same task. So most of the game development companies and game development algorithms that we see work on mostly the principles of reinforcement learning. Now, there's also this branch, within artificial intelligence where we mostly deal with artificial neural networks or ANNs. This is a specialized structure of algorithms that tries to capture the complex relationships and interactions among different components or factors in a statistical model, much like the human brain. There are different types of neural networks. There are, CNNs, which are convoluted neural networks, or RNNs, recurrent neural networks, LSTMs. All of these things are there. Now, one crucial differentiator between typical predictive modeling techniques and neural networks is that of parametric versus non-parametric. On one hand, where parametric tests are those that make assumptions about the parameters of the population distribution from which you are drawing the samples. And on the other hand, in non-parametric methods, there is no assumption about the distribution of the underlying population. So this is a distribution-free kind of an approach. If you go further into the stack, there's something called deep learning. And deep learning is a core subset of machine learning, which gradually improves as more and more data is fed into the system. Now, to check out the difference between different data science roles, you can check out this next video, which data science role you should apply for. And that's all that we had to discuss for today. Hope you have learned something new. If you're looking for private mentorship, career counseling, or practice mock interviews for being well prepared to ace data science interviews, or even if you're looking for some guidance on data science and training, especially if you're a beginner, you may fill up the form below in this description section, and one of our support team members would get in touch with you. Most importantly, if you have liked this video, don't forget to click on the like button, drop in your comments, and don't forget to click on the bell icon and press the subscribe button to stay updated about any of our such new and interesting informational videos that you definitely do not want to miss out. Stay tuned, wait for our next video, and we will catch up soon. Thank you.